Hello once again, it's Matthew from Matthew North Music here. Thanks for tuning into my latest video, and as ever, if you like the kind of videos I make, be them about music, retro technology, or as today, electronics, then please hit the like and subscribe buttons. It really does help the channel to grow, and if you really like what I do, please share the videos on social media, because that's really good to help things move along. Now, the last simple electronics video I did was this, which is the 61J or even 6J1 valve-based preamplifier. Now, in the last video I hadn't quite finished it because there were some parts that hadn't arrived, or rather were missing from the kit. I've since put them in now, the two transistors there was a capacitor there, slightly physically bigger than the others, but same capacitance, same voltage. I also found one of the coupling capacitors that was still in the bag, so I'll pop that in and taken out the other square one, but you know, all works perfectly, and I just thought I'd show this to show that it did actually get finished and it did work. Now, today's video is going to be something, I suppose you could call it a piece of test equipment, but it's also something that when it's working will have lots of flashing lights, and we all like flashing lights. This then is the Zilog Z80. This is probably one of the most famous processors ever made for computers. It's been around for a good 50 years, best part of. It's been in everything from the Sinclair Spectrum, the ZX81. It's in everything. It's used as a processor in disk drives, in computer game consoles. All sorts of things have had the Z80 in it. And so what I've decided to do is to build this. Now, this is a circuit board for testing a Z80 processor. And how it works is relatively straightforward. You have a clock here, which is a 555 timer, and this will then put a pulse into the clock, and the chip will be fed with what's called a no operation instruction, which is 00. So in Z80 machine code, 00 means don't do anything, move on to the next. And the idea is, if you have a working Z80, then each time it does a new instruction, it will then move one on the address bus, and therefore the numbers will increment in binary. So you'll get 1, 2, then both of those 3, 4, that one and that one 5, that one and that one 6, that one 7, etc. And it'll just count up. So what we have is we have a bunch of LEDs along here to indicate the address bus. Each LED needs its own resistor. You've then got a bunch of resistors that are basically feeding into the processor, which should be tied to ground, 0 volts. We've got a little clock circuit here with a potentiometer here for adjusting the speed. And we've got a processor reset switch here, and we even have an LED for the clock. Now, this is supposed to run off a USB power supply, and this board came with a USB power supply connector. That USB power supply connector, which was actually broken. And you could possibly resolder it on here, but I'm not going to bother. I'm going to fix this another way by soldering a couple of wires straight to the board, probably over the power capacitor. Anyhow, I've printed off the list of parts that we need, and basically it's a bunch of LEDs, a few capacitors, a load of resistors, a switch for the reset button, which I might not have. Well, I'll probably have something, but maybe not. It's all you want is those little soft touch buttons. A 500k pot for the clock, which I've probably got. 555 timer, and a ZIF socket. Now, ZIF socket is one of these things, so that will be soldered in, so you can easily pop the chip in there like this. So we get our chip, we pop it in like that, and then we can close it, and then we can do the test. So, as with everything on these projects, the first thing I'm going to do is I'm going to fit all the resistors. Now, according to this, we are going to need 1, 12, 14, 18 resistor, 1k, and we need some 10ks. So I'm going to get those out of the box, and we're going to solder them in. Well, as you look at the board then, all the 10k resistors are effectively all in this row here, which is what's feeding the data bus. So everything from that one, which I think is R30, to that one, They can all be 10Ks, and then there's a 10K there. Once you've got these all soldered in, then the rest are all 1K. So you just fill up all the other resistor holes with the 1K resistors, and they're all resistors for feeding LEDs. So there's one over here because there's an LED there, the power LED. There's one there. In fact, that one might be feeding the power LED. This one might be for something else. But yeah, let's get all these other let's get these soldered in, and then we'll get these put in place. All the resistors are now in. These are a different make to the others, but you know, they're the same value, so always good. Next thing is there's a transistor here, which is a 2N2222. And I bought this ages ago. I think it came from Amazon. And it's a good selection of 750 transistors. And the bulk of these are ones you do see in a lot of these projects. So if you want to get yourself a pack of transistors, then this sort of thing isn't a bad way to go. And certainly I find them very useful. And anyway, let's pop the transistor in, which will go in here. Like that, and then we'll just get that one soldered in. Oh dear, I've got a bridge there. Let's take that out. And reapply the solder. Okay, let's snip the legs off. Okay then, that's our transistor in. The next thing I'm going to do, I think, is probably put in the capacitors, I think. So we've got some electrolytics here, and we've got, I think that's a tantalum or a ceramic there. I think it's probably 100 nanofarads. And again, you know, you can buy these boxes of ceramic capacitors. They're fairly cheap. And here we've got a 10 nanofarad right there. If I can get it out of the box. And it should have 103 written on the side of the capacitor. And it does indeed. You probably can't see it from there because it's so tiny. But anyway, we should pop that one in. And then we've got some electrolytics to go in, which are a 102 tens. And again, like those capacitors, you can buy various kind of multi-packs of capacitors, and they, you know, they do the job. You get everything in there that you need. So I was saying I need 2 10s, which I think I've got in this one here. 3, 4 10s. It's the third one along. Ooh, that's a 50 volt. I've not got any others. No, I haven't. Oh, hang on, I've got them in here. Yes, I've got some in here. Right, let's get out our 2. The only thing is with these packs is you must always close the lid. I had a set of fuses the other day, and I left them open and they all fell on the floor, and they're still waiting to be sorted, which I'll do in a minute. Now, I do actually buy quite a lot of 100 nanofarad capacitors, which have 104 written on, because these are nearly always used for going across the chip, the power supply of chips, to stop any spikes or any problems. Now, I'm going to put our 1 microfarads in there. So there's that one. And then there's that one. I can get it in the hole. Okay, they're in place, so we can flip the board over, and we can get all of these soldered in now. Right, that's all our capacitors in place now. So the next thing, I guess, is going to be our pot there and our timer chip, and then I'm going to pop in all of the LEDs. But let's get these other bits in first. And again, another little multi-pack kit here. These are 500K, or they should be. And this one will fit in the board properly. So we're going to get one of these out, and we're going to pop it in. Now I'm going to pop in the IC holder for the timer, the 555. Turn that over. I'm just going to hold that in my hand, push it up against the board, You can sort of hold this in place with tape or something if you wish, but that's in it, and we can just go over the others. Including redoing the first one, just to make sure it's got a good join. It still hasn't actually. That's better. Okay, there's our IC holder in, so the chip actually goes in upside down. The last thing then is going to be our LEDs, and to be honest, it doesn't really matter what colour LEDs you have. They suggest that the power LED is green, the address line LEDs are red, which is on this side. The clock is yellow and the others are orange. So let's see what I've got in my little pot of LEDs here. So we've got plenty of reds. I've got lots of these like mini LEDs, which I might actually use these because it doesn't matter what size they are. But yeah, we could use those. Okay, well you should be able to see two LEDs that I've popped in. That's our clock, which is flickering away, and actually if we turn the little pot, you can make it go faster or you can make it go slower. And we've got our power LED in there as well. Now the reason I've got power to the board is I've just soldered two wires to my bench supply going across that capacitor, which is one of the filter capacitors or ripple capacitors really, for getting rid of any excess noise on the board. Now this circuit here, that capacitor there, and this resistor here, that's a little network that makes the timing work on the 555, and I think that transistor there is actually like a buffer kind of thing. I think it is anyway, but yeah, all that there is working. So the next thing we need to do is to get all our other LEDs in the board, so we're going to get those soldered in now. One thing I forgot to mention earlier was the polarity of the LEDs. Now on this particular board, the positive leg, the plus, goes into the circle and the shorter negative leg goes into the square, like that. But on some circuit boards it's the other way round, so you do need to double check these things before you solder them in, or else you might have to take them all out and swap them over. One little tip with using these type of LEDs is if you squeeze the legs together slightly and then you push them into the board, then there's enough, if I can get the thing in, there's enough actual strength there that when you turn it upside down they don't fall out. So that makes it much easier for soldering them in. Now they wanted these to be orange, but I didn't have orange, so I've used blue instead. As I say, the colour doesn't make any difference, you can make them any colour you like. Now that's all in, the last thing for now is going to be our ZIF socket, which is going to be this, and that should just pop in like that, and then we just got to solder that in. So let's do that next. Hopefully it will just stand on there. Yeah, it will. So there's no problem with getting this soldered in, it'll just work really well. But again, just push down hard, do that end pin, do that end pin. In fact, maybe do the other corners as well first, and then you can solder the rest. Just take your time because you don't want to short between any of the pins, although there is quite a bit of space really on a processor, but even so. Okay, there it is, it's complete. So what I'm going to do is I'm going to pop in our Z80 into there. Okay, moment of truth then. We are fully assembled, and let's switch the power on and see what happens. And yeah, it's not doing very much, and that's because I think it probably does need an actual reset, and I haven't got a reset switch. I'm just going to use these croc clips and see if we can do a reset. There we go. Now hopefully that should start counting up. So that's 2, 3, 4, 5. So there we go. It's testing the CPU, and it's doing exactly what it's supposed to be doing. So that is a success. I'm going to now look in my box of switches and see if I can find something that will do as a reset switch. Well, the only thing I've actually got is a momentary toggle switch, which probably isn't the most ideal of switches, but you know what, I think it'll do the job. And what I might do is if I connect the outside two together, it doesn't matter then whether you flick it one way or the other, it will still work as a reset. So I'm just going to solder some wire to this. Right, we've got our reset switch in, and again you switch it on and it's kind of not doing a fat lot. So if we just flick the reset switch forward, then it's going to start counting upwards, and if I switch it backwards it should do the same. Yeah, there we go. So a very successful little project that. I've got a couple of other Z80 chips here, so I thought I may as well test them, seeing as this is a Z80 tester. Now we know this one works. I'm going to put that to one side. I'm now going to put in the next chip here, which I will then make sure it's the right polarity, and it is. I'll switch the power on, hit the reset. And yeah, that's counting up. That one works. That's good. Turn the power off. Take the chip out. So we know we've got two good ones. Because I say, when you buy these things from eBay and places, you're never 100% sure whether they're going to be good or not. So I'll try this one now. And we reset. And again, that one's working. So I've got 3 working Z80 chips. That is absolutely excellent news. Well, I hope you found that project of interest. I rather enjoyed putting this together. It's a simple project, and I think if you're someone that maybe has kids and you want to get them into electronics, this is actually probably quite a good little starter project, because you know it doesn't take that much effort to have something that you know, has lots of flashing lights everywhere. Hopefully yours won't have a broken power connector. Now, what I probably could do with this, if you had one with the same problem, is you could just get a normal USB cable, chop off the connector that isn't the one going to the power, use a multimeter to work out which is your positive and minus, and you could literally just solder a cable straight to the board. That's what I'd recommend. However, I've just got some banana plugs on here, and I can plug this into my bench test power supply, of which you must make sure the voltage is correct. So put a multimeter across the power as well to make sure you've got 5 volts, because this is obviously unregulated. Although you could, on the back there, you probably could solder in like a 74L05, the sort of small regulators. You could probably solder one on there and have the wires going to it, and then maybe possibly drill a hole for a cable tie there, and or hot glue it or something. So you could add a regulator to this, but no, as it is, I think this is a pretty good little kit. If you look up these Zilog Z80 testers on the internet, I got this off eBay. I think it was about £5, and yeah, it's a great little kit. Anyway, hope you enjoyed this video. If you have, please like, subscribe and all that, and I'll catch you on the next one.